Here are the notes from Friday. I'm going to go through all of the slides that we did in class as well, so that if you missed something, you guys can get it down, and those that were absent on Friday can also fill in what they missed too over the weekend. So these are homework answers. This is that literal equations worksheet that you guys picked up Friday morning in class and you worked on the first part. So these are the answers for that in case you missed any of them. And I'm going to scroll down here and I have the worked out paper right here. You guys did this on the board in class. So if you need to pause the video right here, do that so you can check your work. And I'll scroll down to the bottom. So there's the rest of it. You can pause it if you need to check your work. Okay, so average rate of change is what we started talking about, and it's the rate of change between any 2 points of a function, and it's a measure of how a quantity changes over some interval, and those intervals are usually over your x values. So we talked about also how we had this slope formula, and it's very similar. It's like y2 minus y1 over x2 minus x1, which is what you guys are familiar with from when you have 2 points, x1, y1, x2, and y2. So you guys are fairly familiar with that. This is just a different way of writing it. F of b right here that you see is the y value when x is b, and f of a is the y value when x is a there. So that's what we're using to find the average rate of change. All right, so we said there's two components to do this. The sentences have to refer to the specific interval for the independent variable, and the calculated rate of change must be identified as an average rate of change. So we also talked about how for quadratics, from one x coordinate to the next, the rate of change is going to be different every time. So here's our first example with Dara. So we use the information to write our ordered pairs there. So if you need to pause the video, if you missed some of this stuff here, 4 p.m., her sales were at 10,550, and at 9 p.m. her sales were at 40,620, and we created two ordered pairs using that information. Okay, so here's the rest of that. If you need to pause the video, do so now. Number 1 and 2, so this is this bottom section down there. So we're just interpreting the average rate of change over intervals. So we're having to create the intervals here. So this one, I'm talking about the population of Austin, Texas in 1990 was 472,000, and the population in 1980 was 346,000. So the average rate of change from 1980 to 1990 is what we're trying to find. So we created two ordered pairs, and we found that rate of change. Okay, so we didn't include the word increasing, but we can see that from 1980 to 1990 that it was increasing, so it would be a positive rate of change. So if you need to pause the video to get this down, do that now. Number 2, we're looking at bacteria growth. So after 1 hour, there were 250 bacteria in the sample, so I've got an ordered pair, 1, 250. Then after 3 hours, there were 1,000 bacteria in the sample, so I have another ordered pair of 3, 1,000. So I found the rate of change, and it was an average of 375 bacteria per hour. So we could say it was growing because it was positive. So if you need to pause the video, do that now. And number 3, we had a concession stand at an amusement park that started the day with 500 popcorn containers. We said that if it's the start of the day, 0 hours have passed. So we can write an ordered pair that to represent that beginning value, 0, 500. We said it's like a y-intercept because it's the starting value. When the graph closes 12 hours late, or when the park closes 12 hours later, excuse me, the inventory, there were 44 containers left. So we made another ordered pair of 12 and 44. So we found the rate of change between those 2 points, and we got a negative, which it makes sense, right? Because from the start of the day to the end of the day, the number of containers left was decreasing, and we found that it was decreasing at an average rate of 38 containers per hour. So pause the video if you need to get some of this stuff down. So now this brings us to number 4. So this is where we stopped in class. So we'll pick up here. So the average rate at which water flows out of a pipe in gallons per hour is given by a continuous function r of time t. The table shows the rate is measured every 3 hours for a 24-hour period. Between 3 and 12 hours, The water is flowing out of the pipe at a faster and faster rate. Determine the average increase of this rate for the 9-hour period. So from 3 to 12, it's spanning 9 hours, right? So I want to know, what is the average rate of the water flowing out? Well, it says between the 3-hour mark and the 12-hour mark. So I could write two ordered pairs. So I get an ordered pair 3, 10.4, and I get an ordered pair 12 12, 11.4. Okay, so I have an x1, a y1, an x2, and a y2. So I can find this average rate of change by taking 11.4 minus 10.4 and dividing it by 12 minus 3. It's the change in y over the change in x. And we end up with 1 over 9. And this is approximately, and I'm saying approximate because I'm rounding, this is approximately 0.11. So what we can say then, it wants to know the average rate of increase for this water flowing out of this pipe during this 9-hour period. So we can say during the 9-hour period, the rate of water flow is increasing at an average, and remember we said yesterday you have to include the word average, at an average rate of 1/9 or approximately 0.11 gallons per hour. Okay, so I just took those the ordered pairs that I found in the table, and I just found the average rate of change between those. So the water was increasing at a rate of 0.11 gallons per hour. Number 5, the temperature in degrees Celsius of the water in a pond is a continuous function W of time t. The table shows the water temperature as recorded every 3 days over a 15-day period. Based on the 3-day intervals shown in the table, over what 3-day intervals is the water temperature increasing most rapidly and how fast is it rising? Over what 3-day interval is the temperature falling most rapidly and how fast is it dropping? So it's asking me two things. So it wants to know over which interval is the water temperature changing, increasing the most, and where is it decreasing the most. So what I'm wanting to do is I want to look at the temperature right over here. So the first interval is from time 0 to 3. So at day 0, the temperature was 20. At day 3, it was 31. So we can see that this temperature here has changed by an increase of 11 degrees. So then from day 3 to day 6, we went from 31 to 28. So that's a decrease of 3 degrees. 28 to 24 is a decrease of 4. 24 to 22 is a decrease of 2, and 22 to 21 is a decrease of 1. So I want to figure out which one is increasing the most or the fastest and which is decreasing the fastest. Well, I see one positive change, and that's that plus 11, right? So I can say that this is the most rapid increase, right? So from day 0 to day 3, we had the most rapid increase. And then if I look for the decrease, which is bigger, -3, -4, -2, or -1, and I see -4 is bigger. Okay, so my rapid increase is what I'm going to look at first. So from day 0 to day 3, the temperature is increasing most rapidly. Okay, so I'm going to find that rate though. So 0, 20, 3, 31, and I can find the average rate of change. 31 minus 20 over 3 minus 0, and 31 minus 20 is 11 over 3, which is approximately 3.67. Okay, so what I can say then is the water temperature So the temperature is increasing at an average rate of 3.67 degrees Celsius, right, per day over the interval 0 to 3, right? So that's the first piece of this. The second piece is where is it decreasing? So we said from day 6, right, to 9 is where we had this decrease of 4. So this span right here. So this is from day 6 to 9, it's the most rapid decrease, right? So how was it decreasing? So we went from 628 to 924. So I can find the average rate of change, 24 minus 28 over 9 minus 6, and that gives me -4 over 3. And we expected that, right? Because it's a negative and it's decreasing. So we would expect a negative average rate of change. So it's approximately -1.3. So we could say that, let me extend this page really quickly. We could say that the temperature of the water is decreasing at an average rate of 1.3 degrees Celsius per day over the interval 6 to 9, and I should probably add days in there, 6 to 9 days. Same thing up here with the 0 to 3. We should make that say over the interval of 0 to 3 days. So we found which was increasing the fastest, and we found that rate of increase, and then we found which was decreasing the fastest, and we found that rate of change too. Notice I didn't write -1.3 degrees Celsius down here in the second one, and the reason is I used this word decreasing. So decreasing, the word decreasing is indicating that the rate of change is negative, and up in that first part, the word increasing is indicating that it is a positive average rate of change. Okay? And number 6. So calculate the average rate of change for the function f of x equals x squared plus 6x plus 9 between x equals 1 and x equals 3. So I'm giving you guys two x values, and I want you to find the rate of change. Well, we know if we try to find the rate of change, you need x's and y's. So if you know x's, can't you find y's for that value? X is an input, and your y is the output. So all you need to do is plug in. So step 1, we're going to plug in this x equals 3. So we're going to evaluate the function at 3, and we get 3 squared plus 6 times 3 plus 9. Right, so you get 9 plus 18 plus 9, which is going to give you 36. So this right here is going to give me an ordered pair. The input was 3, the output is 36. So it's an ordered pair, 3, 36, right? And then if I plug in x1, or x equals 1, I get 1 squared plus 6 times 1, not 3, plus 9. So I get 1 plus 6 plus 9, which gives me a 16. So the input was 1, the output is 16. So that's going to give me an ordered pair 1, 16. All right, this is technically my x1. This is my x2, right? That came first. So if I needed to come back and just kind of think for a second, this is x1, this is y1, this is x2, this is y2. It doesn't matter as long as you keep them the same, but I just like to make sure that I know which is my first coordinate, which was here, and the second coordinate. I usually go from left to right, and I know that x equals 1 is smaller than x equals 3 on a graph. So I'm going to find the average rate of change, and then I remember y2 minus y1 over x2 minus x1 when I have ordered pairs. So this gives me 16 minus 36 over 1 minus 3. That's going to give you a -20 over -2, which is positive 10, right? So the average rate of change is 10. Okay? Alrighty. Oh, I'm sorry. I just wrote that backwards. I was wondering why this looked like this. This was not how I labeled it. You're still going to get the same answer, so scratch that. Actually, what we said y2 was 36, and y1 was 16, and we said x2 was 3, and x1 was 1. There we go. That looks much better. Now it's all positives. And we still get the same thing, right? Remember I told you it doesn't matter which x1 and y1 you label your point, x1, y1, x2, y2. It doesn't matter which one that you name your first point and your second point, as long as when you plug it into the equation, you plug it in correctly, you still get the same thing, which is what we just saw. But I wanted to make this match what we labeled our points as up there. So the average rate of change over that interval is 10. Okay. So number 7. So the function g of x equals x minus 3 squared minus 2. We want to find the average. Is the average rate of change greater between the interval -1 to 0 or 1 to 2? So I've got x values. So basically what I need to do is I need to figure out the rate of change, the average rate of change from -1 to 0, and figure out the average rate of change from 1 to 2. So the first thing I need to do is plug in each of these 2 points and find the average rate of change there. So I'm going to plug in a -1 into my function. I get -1 minus 3 squared minus 2. All right, and that's going to give you -1 minus 3 is -14. -14 squared is 16, and 16 minus 2 is 14. So the ordered pair here is -1, 14. Then I'm going to plug in a 0. 0 minus 3 squared minus 2. So 0 minus 3 is -3. -3 squared is 9. 9 minus 2 is 7. So the ordered pair is 0, 7. So I'm going to find the rate of change, the average rate of change, y2 minus y1, x2 minus x1. So that's going to give me 7 minus 14 over 0 minus -1. Minus a negative becomes a positive. I get -7 over 1, which is -7. So that's that first interval right here. -1 to 0, the average rate of change is -7. All right, so the next one is between 1 and 2. So I'm going to plug in g of 1, and I get 1 minus 3 squared minus 2. And that's going to give you 1 minus 3 is -2. -2 squared is +4, and 4 minus 2 is 2. So this gives me the ordered pair of 1, 2. Then I'm going to plug in a 2. So g of 2 is 2 minus 3 squared minus 2. 2 minus 3 is -1, and -1 squared is 1, and 1 minus 2 is -1. So I get the ordered pair 2, -1. So then I'm going to find the average rate of change here, and I get y2 minus y1, -1 minus 2 over 2 minus 1, -3 over 1, which is -3. So each of these are decreasing. I have one that's decreasing at a rate of change of 7 and one decreasing at a rate of change of 3. So which is greater, 7 or 3? 7, right? So the average rate of change is going to be greater between -1 and 0. Even though they're both negative, when we talk about which is bigger, we kind of ignore signs. It's like looking at the absolute value of that number, and the absolute value of 7 is 7. So that is decreasing faster than the other interval. So the average rate of change is greater between x equals -1 and x equals 0. Number 8, this is our last one. So I want to use the graph to calculate the average rate of change between x equals -3 and x equals -2. So x equals -3 is going to be found right here on this graph, right? It's this vertical line here. All right, and I have this coordinate right here. That's the point, -3, +1. And -2 is somewhere right here. Well, here's where I'm intersecting the graph. So this is -2, -2, right? So I'm going to do this algebraically first, and then I'm going to show you how you can do this graphically, which is what we've been doing when we were doing graph characteristics of quadratics earlier. So the first thing I want to do is I'm going to figure out the y value when x is -3, and we've already done that, right? We got the ordered pair -3, 1, and then the same thing here. When x was -2, I got the point -2, -2. So I can algebraically find this rate of change by doing the average rate of change is y2 minus y1 over x2 minus x1. So -2 minus 1 over -2 minus -3. That becomes plus plus, right? Minus the negative is a positive. -3 over 1, and I get a -3. So the average rate of change over that interval is -3. So my question is, if I find these two coordinates here, if I know I'm looking at x equals -3 and x equals -2, I'm wanting to know the rate of change of this piece of this graph, correct? So what I could do, let me erase some of this red from here so we don't get confused. Couldn't I technically, if I know rate of change is also your slope or rise over run, could I calculate the rise over the run right here? So if I look, that box to go away, there we go. So I'm rising 1, 2, 3 units, right? So this is rising 3, and we're running to the left 1 unit. Well, if I'm rising and running, or sometimes you guys look at it as you decreased 3, you went down 3 and right 1, isn't that a negative right there? So couldn't I just say this is a -3 over 1, -3 slope, which is what we got when we did this algebraically? Both ways work. So if you've been given a graph, you can always find the x values, the intervals that they give you using the x values, and you can calculate rate of change by doing rise over run on a graph. But you can also do the algebraic method as well. Okay, so those are all your notes from Friday.